Hi, everyone. So welcome to this Wednesday asynchronous day. We're not going to have a lot of these days, but we will this week. Normally, we'll be doing like quiz retakes or something like that on this day. But for today, we're going to be finishing up this lesson here, this lesson 2. We're on 2.4 right now, so which is on page 37 of your little half book there. So looks like we're going to be exploring factored form. So if you look right here, it says a group of students each write a quadratic function in factored form to represent a parabola that opens downward, right? Opens this way, and has zeros at 4 and -1. All right, so we're going to just draw these in here. So it's going to be here at 4. Just make one at 4 and here at -1. Right, and then if you notice right here, these ones have the thumbs up. So they did a good job. So Maureen and Tom, good job. However, Tim and Michael, they did something wrong. So if you take a look at these and let's see what the differences are, right? Because we didn't really talk about the graphing yet. We do know that this does open down, so it's going to open down at some point. So it's going to like go like this, right? But we don't know like how high or whatever. But we do know this is that, so notice right here, this open down, we do know that this first number right here, that has to be negative, and that's what this has. One has a -1 and one has a -2, which is fine. It did not, this above thing did not, this did not say like whether it, what number it should be, right? So we just do know that it is negative though. So it looks like Michael's got that right as well. And it looks like that was Tom's issue here, right? So they should have put in that negative in there, but they don't have that. So that should have been a negative. All right, another thing that you notice in here, if you notice, this is a 4. So here there was a minus. Remember the formula was supposed to be for a factored form. It was going to be f of x is equal to a times x minus r1 times x minus r2. Right? So literally we were just taking out the R1s and then putting in the first root, take out the R2 and put in the second root, right? So this should be a minus there. So x minus 4, right? So they're making this x be the root 1. This is the first root and this is going to be the second root. Honestly, those orders does not matter, okay? And so, and they have this plus 1. How did they get the plus 1? If you think about it, remember it's going to be, so x minus 4, right? So it was supposed to be x minus. And what is that second root? That's going to be -1, right? So we have, it's a minus a -1, right? So those two negatives right there, minus a negative, they make a plus, all right? So that's why it is, where's my mouse? So that's why it's shown here as a plus. So yes, this is the way you're supposed to write it. So, and if you notice right here, that's where Michael messed up as well, right? He mixed up on the minuses right there. Oh, that's so close. Tim was so close. All Tim needed to do was add in that negative for the 2. And then actually his equation would have been exactly the same as Tom's. Oh, well, too bad. So we do know that it's going to look something like this. So one of them is going to look like this. The other one is going to go through the exact same 2 points through roots, except notice this is -2. Think it's got elongated because it's twice as high now, right? So the second one is going to look like this. So still going through those points, but now it's just twice as high. Okay, so that's what it's going to look like because it's getting multiplied by 2 instead of being multiplied by 1. All right, something like that. I'm not going to sketch the other ones because they're wrong, so we're not going to go into that. But if you notice here, for Tim's, it's going to look very much like these two, except instead of opening down, it's going to open up because remember, that one is positive, so it would look exactly like Tom's graph, except this way, okay? And then Michael's one, notice that he got the roots backwards. So instead of being at -1, it would be at +1. Instead of being at 4, it would be over here at -4. So that would be flip-flopped, okay? And then, it would have been upside down. So it would have had the same height as the blue one right here, as Maureen's, okay? So that would be the differences. If we're going to take a look at this, so remember, consider the quadratic. So we're going on to the next page. This is on page 38. We're just flipping pages here. And it says, consider a quadratic function written in factored form. So again, we have this factored form. And what does the sign of the a value tell you about the graph? You remember what it was? So the A value is this guy right here, is that number in front, right? And remember we talked about that, and it talks about, it tells us the concavity, right? So concavity of the graph, or if you want to write down if it's open up or open down, or you can draw a picture, right? So remember the picture that we drew for this, the A, remember if it's positive, it's open up. And if it's negative, it's open down, okay? And then what does the R1 and the R2 tell you about the graph? Remember what the R stands for? Do you remember? So it talks about the roots. And what were the roots representing? AKA the x-intercepts. All right. And so that's going to be the factored form. So factored form is really nice because it tells us about whether it's open up or open down, and also the roots, right? So that's it's really useful. You don't even have to calculate the roots, right? So factored form is pretty nice that way. And we're going to now move on. We're not going to do this part right here. We're going to just go down. I'm going to skip down to what page is this? Page 40. Okay. So it says for each quadratic function, we're going to do a couple of things here. So we're going to do number 1, which is use a general form to determine the axis of symmetry, the absolute maximum or the minimum, depending, the y-intercept, and we're gonna graph it using these things, right? So let's go. So it says the axis of symmetry. So let's determine the axis of symmetry. So AOS, I always like to write my work like this. So x equals to, remember it's negative b over 2a. Well, remember how to get the a and the b? So remember it's the numbers in front of that. So it's going to be a is equal to 1, b is equal to negative 8, and c is equal to 12, right? So, and we're getting them, these are the numbers that are in front of the variables. And then the c is always that last one that has no variables next to it, right? Of course, we don't need c yet. So we will need c, just not yet, next unit. All right, so we're going to plug this in. So we're going to go x equals to negative. So this negative has nothing to do with that negative, right? So negative of negative 8. And then 2 times a, which is 1. So, well, what's the negative of negative 8? Positive 8. And then 2 times 1 is 2. So this is just equal to 4. So again, we're going to rewrite this. So the AOS is x equals to 4. Remember, AOS is not a value, it is an equation, right? So we need that equation so we know it is at x equals to 4. I'm just going to go 1, 2, 3, 4. This is 4 right here, and this is my AOS. Remember, it's a dotted line because it's just a reference point, right? Or a reference line, I should say. Now, the next thing that we're going to do here is, it says find the absolute minimum or maximum. The way we're going to do that is by finding the vertex. Now, how do we find the vertex? We know that the vertex is somewhere on the AOS, right? So what we're going to do is, well, we know the function is h of x, right? So we're going to plug in x. So instead of x, we're going to put in 4. So anytime you see an x, you're going to put in a 4, okay? So, ooh, I see an x here. So we're going to go 4 squared minus 8 times, oh, I see another x. So there's going to be I'm going to replace it with a 4 plus 12. That's what this x means. So this, so when we have function notation, what I really like about function notation is that we don't have to say, well, what is y when x is equal to 4? We just say, what is h of 4? That's it. It makes it a lot more simple. So here I'm just showing you that, oh, I've just replaced the x with 4. So I'm just trying to evaluate the function when x is equal to 4, right? This is not h times 4. It's nothing like that, okay? So h of 4, we just leave it like that. And so that's going to be 4 squared. Remember, order of operations always in play. So that's going to be 16. And then minus, this is 32. 8 times 4 is 32 plus 12. Now we're going to go left to right. So we're going to subtract first, and then we're going to add. You do not add 32 plus 12 first, right? Because technically, that's not a 32. That's a negative 32. So if you want to take the negative along with you, then you could totally do that, okay? But 16 minus 32 is negative 16 plus 12, and that's going to be negative 4, okay? So basically what I'm saying is that my vertex is going to be 4, comma, negative 4. All right, so we're going to go down here. 1, 2, 3, 4, about the same spacing. And that's going to be our vertex right there. So this, what we just found out right now, we found out the vertex. And that's going to tell us if we have a min or a max. And is this a min or a max? Does it open up or open down? If you look right here, this is positive, right? And so remember, if it's positive, it does open up. So it is going to go like this. And the other thing that we need to note is, well, there's one more thing that we need to find out. It says the y-intercept, right? So our y-intercept, remember, somebody had taken note of it, just like how we do for our y equals mx plus b, right? That plus b part was the y-intercept. It's the same thing here. And how do we know that this is the y-intercept? Well, if you want, what is the value of x on the y-axis? It's 0, right? Because literally we're not going left or right on the x-axis, right? So I'm going to put in here, so y-intercept. Oh, let me do that. Let's make that green. So our y-intercept, here's my work for the y-intercept. This is when x is equal to 0. So h of 0. So anywhere I put in an x, I'm going to put in a 0. Anywhere I see an x, I'm going to put in a 0. So again, this is going to be 0 squared minus 8 times 0 plus 12. Well, what's 0 squared? 0. What is 8 times 0? 0. So this is literally 0 minus 0 plus 0, not plus 0, plus 12, which is literally 12. So this is y. So this is literally equal to 12, right? So this is why the y-intercept is just that part, because all the other stuff cancels out. It's just 0, right? So our y-intercept is going to be 0, 12. Okay, and that's going to be our, so we're going to go all the way up here. Okay, this is me being lazy. This is 12. Okay, so how far is 12 away from the AOS, right? It is 4 away, right? We can tell. So 4 away. So we actually do know the other point. Remember, it's reflected on the other side. So if we count 4 more away, 1, 2, 3, 4, we know that that's also a point here. So if we know one point on one side, we know the reflected point over on the other side. So we're just going to be like, okay, let's see if we can be as accurate as we can, right? And then we're going to go, this says draw a parabola. Okay, it's right about there. We'll see how close we are with the roots, okay? I don't know. I think I'm a little off on the left-hand side, right? It looks a little fat right there. So probably it should be like maybe crossing the 2. We'll see. So, and it says right here, so now we're finished with 1. We've graphed it, labeling, oh, we got to label the characteristics. We totally didn't do that. Oops. So remember, this was our y-intercept. This is our vertex, which is also our minimum, right? Remember minimum. And this is our AOS. Okay. All right, and it says use technology to identify the zeros. Okay, so what does that mean, use technology? Like graph it. So we're gonna use, and this is the only unit we're gonna actually just graph it on a graphing calculator. The next unit I'm gonna show you how to actually find the roots and stuff like that. So we don't have to use a graphing calculator. But for now, just for now, we're going to copy this in there. So let me just go like that, scooch that over, that here so I can see the equation. So we have, you do not need to put y equals, okay? We're just gonna go x squared minus 8x plus 12. All right, and if you notice right here, it'll tell you, oh, look, vertex, 4, -4. That's exactly what we got. Yay, happy days, right? And then here, the roots are going to be at 2 and 6. And let's just check our y-intercept. Is it really at 12? Yep, look, see, 12, happy days. All right, so, oh, well, what are the roots again? Did you remember? It was 2 and 6. So if we look right over here, was I close? Yeah, I was close. Oh, where's my mouse? Mouse, where are you? Okay, here. So it should be right here at 2 and at 6. So do you see, I knew I was a little bit fat on that side. It was like a little bit wide. But yeah, so my zeros are at 2, 0 and 6, 0. All right, so if that's where my zeros are at, see, do you see how they put zeros in here? They just randomly put them. That's also your roots, which are also known as, what are they called again? As x-intercepts. Okay, so please do not get confused. Remember, I told you there were 3 different ways. I forgot that they introduced it here, right? But zeros, why do they call them zeros? Because that's where y is equal to 0, okay? And that's gonna be important later on. We're just not dealing with that yet. Okay, so that's where that is. So now we can write it in factored form, right? So remember they're using h of x, so we're going to copy down that h of x because this is actually representing the exact same graph, so the exact same function. We're just changing, we're just changing the way it looks. So what was the a for, okay, let me just write this down. Remember normally it was a times x minus r1, x minus r2. So remember our a is the same as this a right here, and we had defined this a to be 1. So technically we don't have to write 1 in there, we just put parentheses, and we just assume that's a 1 in front, right? If you want to put in the 1, you totally can. So I'm just going to copy this part down, so it's just x minus, and now we're going to put in the roots, right? So it says 2, and the next one is going to be 6. Honestly, if you wrote down 6 first and then the 2, that's fine, because honestly, with the parentheses, we're just multiplying them, so it doesn't matter which order they go in. Okay, so if you wrote down x minus 6 first, and then you did x minus 2, that's okay. It's the same thing, right? And you just make sure you put in the h of x. The same thing. All right. So now we wrote that down, and then it says, so we labeled and used the technology. We did that. So it says draw the it says graph and label each characteristic. I was a little bit too fast on that. Sorry. Now we're supposed to draw the parabola, which we already did. Happy days. So we'll do that for the next one. And it says verify the function you wrote in factor form as is equivalent to the other one. And how do we verify that? We're just going to graph it. Okay, so I'm going to take this out. I'm just going to make it invisible for right now. And we're going to put in the other one. So it's x minus 2, right? Don't mind that line right there. And this is x minus 6. If you notice, okay, so notice it has the same things, but also another thing to notice, if I turn this back on, you see how it's exactly the same line, right? That's my proof to you. All right, it's proof in the pudding. I don't know why they say that. All right, so let's try that for this one, okay? And please, I would pause right now, do this yourself. Try it yourself, do it, and then watch and do it together, and you can compare and see if you did it right. Okay, that's the best way to do that. All right, so here we go again. You paused it, right? You did a thing. Okay, so again, first thing first, we're gonna find the AOS. Okay, first thing is, remember, it's x is equal to negative b over 2a. And we're defining our a as negative 2, b is going to be 6, and c is going to be 20. All right. So if you want to color coordinate that, I can totally do that for you. Here's my a. Notice there's no more x in there, right? That you should not see an x. There's my 6. It is a positive 6 because this is a plus 6. And my c is going to be the plus 20, which we don't need. We will need that later, but we don't need it right now. All right, and then so we're going to just substitute that in. So x is equal to negative, and what is my b? 6 over 2 times negative 2, right? Just to keep these colors consistent, my b is right here, so which is right here. Remember, it has nothing to do with that negative on the outside. So, and then we want our a, so our a is right here. So our a is right here. Okay, so hopefully those colors help you. Go back to my purple, and we're just going to reduce this guy, so it's negative 6 times negative 4, which is actually equal to 6/4 is negative divided by positive, which is goes in there 1 time 1.5, so 1.5. You can use a calculator if you want to, that's fine. So our AOS is equal to 1.5. So I'm going to just draw that in there. So it's going to be, here's 1, here's 2, here's 3. My 1.5 is like halfway in between. So there's my line, making it dotted because it's actually not part of the quadratic, of the parabola. All right, and the other thing we needed to know was the vertex. Oh, I should probably write down this, the AOS. Okay, and then my vertex. Remember, my vertex is somewhere on the AOS, right? We just don't know where, it's just somewhere. So what we're going to do is we're going to plug in this x, right? We know what the x is. We just need to know the y part, right? So we're going to plug it in. So r of 1.5. And so remember, anytime you see an x, you're going to put in a 1.5. I think we have a calculator. So negative 2 times 1.5 squared. We're getting off of here. So plus 6 times 1.5. I write big here, plus 20, right? So we're going to use our calculators. So do it well. So negative 2 times, totally totally did that wrong. So -2, make sure you're not doing -2. 1.5 squared plus 6 times 1.5 plus 20. Don't just wait for me, you do it too, okay? Because the first time you use this calculator to try a calculator thing should not be on the test, okay? You need to calculate this out, and hopefully you get 24.5. Because if you didn't, either you did something wrong or I did something wrong. I'm pretty sure that's right though. So here we go. So this is going to be 24.5. So our vertex is going to be 1.5 and 24. Okay, so on here is going to be 24.5. We're going to make that 25. So this is going to be a little bit lower than that. So just like that. So hopefully this is open down, because if it's open up, this is going to be really, really tall. Okay, like most of it's not on this graph, right? And if you notice right here, it is a negative. A is negative, so we do know it is open. So few. All right, and then the last thing we need to calculate out is our vertex. No, we already did vertex. Y-intercept. And put that right over here because I don't have much room. So y-intercept is going to be, remember, just this right here. So we could just write that down. You don't have to show all the work unless you want to, and then totally feel free to. So if we're going by 5, so 5, 10, 15, 20, 25, so something like that. So this is 20 right here. Okay, so this is my y-intercept. All right, oh, I totally forgot about vertex. Oh, it looks like my AOS is the same thing. All right, let's try this out. So my vertex is like right there. So we'll say vertex. And my AOS is going to be this guy right here. And I'm going to keep on going. So we have our, oh, we also do know the other point that's reflected on. Remember, this is like 1.5 away. So on the other side at 3, that's like our other reflected point, right? Just to be a little more accurate, right? Where, you know, it's going to be like wide like this, right? And so we need to find our roots. So let's graph this guy. Okay, take these guys out. And we're going to be like -2 x squared. And honestly, if you want to put the x, actually, you can use the caret to kind of help you with that squared thing. Just move it over to the right. And then it's going to be plus 6x plus 20. Honestly, though, you probably use, if you're using your phone, you have this part down here. So you have the square button is right here for you. So you can just push that if you want to, instead of doing x twice. That's up to you. Oh, look, what? No graph. Oh, probably because I put equals. I don't want to put plus. Ah, there we go, graph. Oh, it's a nice green color. All right, so if you'll take a look right here, yep, were we right? Is it 1.5 and 24.5? Yep, there we go. So we were right, and our y-intercept is at 20. Now we can find our x and y, the x-intercepts, the roots. So it's at -2 and 5. So we're going to put that in there. So at -2, we're going to go same spacing as on the x-axis. So this is -2 and 5, 4, 5 right here. So now we're going to make this graph. Let's try this out. Oh, we should probably write that down. So it's 2, 0, and 5, 0. You're like, wait, Miss Lee, it's wrong. It's not 2. Yep, very good. -2. There we go. Let's draw our graph. So is it going to be kind of wide? Oh, let's try that again. Kind of-ish. Okay, it's supposed to go through that point. Pretend that it did. All right, use your imagination. It's a little bit wide, but yes, it's kind of like that. But remember, my spacing is a little bit weird here, so that's why it looks a little bit strange. But that's what that's going to look like. Now we can write it in factored form. So this is going to be, we're going to take the same r of x. So r of x just like this. Remember, it's going to take on the same a. A was -2, so it's going to be -2 as well. And then x minus, and then x minus. I like to set it up first. So what are my roots? One's at -2, so I'm watch what I'm doing, right? -2. This is me being lazy because I don't want to like rewrite a thing, right? And then the other one is 5. Okay, notice that minus and negative, remember, same thing as a plus. So I just made that negative into a plus. Okay, and then 2. That's how I like to deal with it. So that's -2. So that's going to be our formula, or not formula, but that's going to be the factored form. So these two are the same. Just for proof, just in case you like still, because seeing is believing sometimes. I'm gonna write this in here. Come on. All right, so this is going to be -2 parentheses x plus 2, oh, not 9, x minus 5. It already has end parentheses form, but I'll just write it. And notice, look, exactly the same, right? See, it maps totally onto itself, right? So yeah, there's my proof for you, right? Even all the way at the top. See, same. All right. I could do more. But we're going to stop right there. If you're a little bit concerned, like you don't know how to do this, I would watch that again. Well, shall we do one more? Okay, let's do one more. Shall we do C or shall we do D? Let's do D, because D seems interesting, because this one doesn't have an X, right? And this one does, right? It just doesn't have a C. So we still have an A and B. So it's still the same as the stuff before. But this one literally does not have an X. So what do we do? That'll be a good one. Okay, so let's do D. All right, let's start from the beginning. So again, remember, we're doing the AOS. Okay, so pause, okay, do it first, and then try it out, get as far as you can, and then watch the video. Good job. Hopefully you're there. Hopefully you did that. All right, so remember, we're finding our AOS. So it is going to be x is equal to -b over 2a. And what we're going to do here, again, we're going to define this. So a is equal to 3, b is equal to, now remember, like we have no x, so what's literally in front of the x? A 0, right? That's the only way that x disappears, if it gets multiplied by a 0, right? So this is going to be 0, and then c is going to be -3. Okay, so that's what happens. So we're now going to just plug this in, right? So x is equal to -b, so -0 divided by 2 times 3, because the 3 is the a, right? And what's 0 divided by 6? 0, right? So literally your AOS is just x equals to 0. Where is that located? Where is x equal to 0? Right here on the y-axis. So this is your AOS, like literally. AOS. All right, and then we're going to do the same, see how everything is exactly the same. So now we're going to find our vertex, our min or max, right? So our vertex is going, we're just plugging this in, right? So instead of x, we're going to put in 0. So it's c of x, so c of 0 is equal to 3 times 0 squared minus 3. Well, we know 0 squared is 0, 0 times 3 is 0. So 0 minus 3 is -3. So our vertex is going to be at 0, -3. So we're going to go 1, 2, 3. This is -3, which happens to also be our y-intercept. Okay, so the vertex is the y-intercept. They're the same thing, right? That's what happens when your AOS is on the y-axis. It's just the way it is. Okay, now we need to know, we don't have any other information other than that, so we're going to have to graph this guy. So let's take our graph. X is out. Oop, X is out. And we're going to go 3x squared minus 3. And if you notice right here, let's go down here. Our roots are here at -1 and +1. Notice, just like how we said, our vertex is at -3, right? So -1 and +1. So we're going to write that down. So it's, so -1 and +1. And so here's 1 at -1, 1 at +1. And literally, we can just draw it right now. Not terrible, right? But that's what that's going to look like. And our factored form would then be, remember, c of x is equal to, our a is 3, so 3 parentheses, x minus, right? And then we have 1 at -1 and 1 at +1. So remember what I said to do, right? So it's going to be 1 at -1, so -1, 1 at +1. Say we made one that minus into a plus, and then, so this is literally what it's going to look like. Okay, okies? And that's in factored form. And if you don't believe me, I know you do, but if you didn't believe me, let's see if I can write it out. So x minus 1, x plus 1. And you're like, Miss Lee, you did it backwards. That doesn't matter. It's still multiplying. Does not matter, right? And if you really don't believe me, you want me to do it the other way around. So go x plus 1, x minus 1, which is what I wrote down. If you notice, blue is the same as the red, which is the same as the black. They're all the same. This is my proof to you, right? All right. Happy days. So now we know what to do with that. So you're going to be doing 43 and 44. That's your homework. I'm going to go through them. And so if you want to check how to check and see if you did it right, this is where you're going to do that. Okay. Or you can just skip to the end and see if you can just check your work. It's up to you. This is asynchronous. It's up to you. All right. So we're going to, it says, do not use technology. So we're not going to use our we can use your calculus to calculate things, like if you don't know how to multiply a thing or subtract or add a thing or divide a thing, but we're not going to use it to graph. We're not graphing anything. This is what it means, is the intention behind that. All right, so determine the axis of symmetry of each parabola, right? So the intercepts of the parabola are 1 and 5, right? I like to kind of draw pictures so I can kind of see what's going on here. So here's 1, here's 5, right? And those are the roots. Where is the axis of symmetry? Remember, it's going to be halfway in between. So literally, we're just going to add them up and divide it by 2, right? So so x is equal to 1 plus 5 and divided by 2. So which is going to be 1 plus 5 is 6 divided by 2, which is 3. And on it, so okay, we can't just leave it like that. We have to say x is equal to 3. That would be our AOS. So if you did like you did the counting in, right? So if you got, where is it? So we go 1, 2 in, 1, 2 in. So that's going to be 2, 3. From here, we're going to go 4, 3, right? That's going to be your middle number right here, the 3, right? So x equals to 3. If you want to do it that way. But this is just better. This is to show your work of like calculating, because I literally can't see you like do this, right? And so what if your x-intercepts of the parabola are at negative 3.5 and 4.1? See how this is a little bit more difficult? We can still use that concept of, you know, finding the average, right? Finding the mean. So it's going to be negative 3.5 plus 4.1, divide that by 2 is equal to, so negative 3.5 plus 4.1 is, we're like subtracting. So that's like 0.6. Okay, I need to make sure. Oh shoot, my night brain is not working for me. 0.6, yep, 0.6, just to make sure. I want to give you the wrong answer here. So 0.6 or 0.6 over 2. And if you divide that by 2, it's like 60 cents divided by 2, right? It's 30 cents. So it's just going to be 0.3. Oh, I made a mistake. My bad. I didn't write it as an answer. Ooh. X is equal to 0.3. Okay, so right at 0.3, that's going to be your AOS. And oh, what if we have two symmetric points, right? They're not roots, but they're two symmetric points. So remember when we talked about the distances between the two points that are symmetric to each other? We're just going to look at the x's, right? So that distance is literally the same thing. So x is equal to this -7 and the 0. So -7 plus 0 divided by 2, which is equal to -7 over 2, which is equal to -3.5. So x is equal to -3.5. Okay, literally does not matter. We just look at the x parts and add them up divided by 2, because the distance are equal to each other. So we're literally finding the mean. Okay, and describe how, well, I just described how you did that. Okay, you find the average of the two points, right? And it can't be just any random 2 points. It has to be two symmetric points. Okay, and if they're not symmetric, then it doesn't work. And as you know, roots symmetric. Right, so it says determine the location of the vertex of each parabola. What am I doing? The vertex. Okay, so the function is this, and has an axis of symmetry at -2, right? So remember, we know that the axis of symmetry has that vertex, has a vertex on there, right? So literally, we're just plugging it in. So here, f of -2 is equal to, anywhere we see an x, we're going to put in a -2. So we're going to go -2 squared plus 4 times -2 plus 3. Then we're going to go, okay, exponents first, and -2 squared is 4, plus this is going to be -8, and then plus 3. I suppose I could have put a minus, but I already put down a plus, so I was committed to that. So -4 minus 8 is going to be -4. plus 3 is going to be -1. So this whole thing is going to be -1. So I'm going to write down that says the vertex. So my vertex is going to be -2, -1. All right. Oh, I didn't finish it out. So remember my x is right here, which is found right here. These are all the same, so that's why we see it here. Okay, and then my answer, my result is going to be the -1. That's what we get. All right, so let's try another one. So the equation of the parabola is this, and the x-intercepts are that. Okay, and we're supposed to find the vertex. Well, I guess we're going to have to find the AOS first, right? Well, if I know the x-intercepts, that's probably easier to calculate than the other way, the standard form way. So if it's at one's at -2, one's at +2, it's the middle part at 0, right? So my AOS is 0. But if you didn't know that, if you're like, that must I don't know. So I'll show you. So -2 plus 2 over 2 is divided by 2. I don't know why I was going to try and write 4. So -2 plus 2, that's 0. 0 divided by 2 is 0. And it's like I told you, x is equal to 0. This is our AOS. Okay? So now that we have the AOS part, we can find out the y coordinate part, right, by plugging it in. So we're going to go, well, y is, because it's not giving us a function, so let's go y. So y is equal to, instead of x, we're going to put in 0 squared minus 4. All right? And when that, so what would my y equal to? That's 0, so it's -4. There we go. So my vertex is 0, 0, -4, which is also apparently the y-intercept, but that's okay. That's still a vertex, right? There we go. All right, so then number C. We're still finding the vertex here. So we are given two symmetric points. Remember, we don't care what the y is. We don't care how high or how low it is. We just care about the x parts because we want to know that distance. So we're going to say x is equal to, here's from -1 plus -5. And what's in between that? Maybe you guys can figure it out already, but that's fine. So that's going to be -6 divided by 2, which is going to be -3. So my AOS is x is equal to -3. But that's not what I want. That's part of what I want. I want to know the whole vertex, right? We just got the x coordinate. We want the y coordinate, so we're going to literally just plug that in, like we've been doing this whole time. All right, so that's going to be -3 squared plus 6 times -3 minus 5. So anywhere we see an x, we're going to put in a -3. All right, so then we're going to get -3 squared is -3 times -3, which is 9, plus 6 times -3 is -18, minus 5. So that's going to be -9 plus -18, -9, minus 5 is -14. So that's going to be -14. So my vertex is going to be -3, -14. Boom, just like that. All right, so how do we determine the vertex? Given the equation and the axis of symmetry. So plug in the axis of symmetry into the equation and get the y coordinate, right? So plug in to function to get y coordinate. Oh, that's terrible. That's not even how you spell that. Coordinate. All right. We're almost there. Home stretch, guys. Home stretch. All right. So determine another point on each parabola. So if we know that the axis of symmetry is 2, okay, so visualize it, and a point on the parabola is 0, 5. What is the other point, right? I like to draw a little. So if we have the axis of symmetry here, and we know that one of the points is, oh, this is x equals to 2, right? This is 0, 5, so 0 is on to the left of x is equal to 2, right? So this is 0, 5, right? So we know how high it is. So the other point right here on this other side is going to be something 5, right? We just don't know what that is. So how far is 0 to the axis of symmetry? It's 2 away. So let's add 2 more to the other side. So that's going to be 2 plus 2, which is 4. Do you see that? So the answer is just 4, 5. Remember, it's going to take the same height as the other point. And again, so the vertex is, okay, so now we know the vertex. which means we also know the AOS, right? So the AOS right here, this is going to be at x is equal to 0.5. Oh, we don't need that. And then, and it's going to be at 9. So this is, honestly, it doesn't matter what that is. We just want the AOS part. And the x-intercept is at -2. So here's a point right here. So this is a -2.5, 0. So remember, it's going to have the same height as that. So it's going to be also then another root over here. So it's going to be something 0. So what is that something going to be? So how far is the -2.5 from the 0.5? Well, from 0.5 to 0 is 0.5. And then from 0 to -2.5, that's, so altogether, that's going to be 3. That is 3 away, right? Because here's like 0, right? This is like 0. It's not drawn to scale, guys. So from here to here, that's 0.5. And then from 0 to -2.5 is 2.5. So that distance is, total distance is going to be 3. So it's going to be 3 on the other side. Ooh. So it's from 0.5 to 3. Well, what's 0.5 plus 3? 3.5. Hopefully you got that. Was that confusing? So let's try this one more time, because I feel like that was confusing. Here's 0, right? Here's 1, so 0.5 is like right here. Right? This is 0.5. So, and this is our axis of symmetry right here. And so we know our point is over here at negative, what is it, -2.5, so -1, -2. So this is -2, -3, -2.5 is right here. So how far is this? Well, we're like, well, this is half away. And then, so this is like half and then 2. So that's 2.5 plus another half, so that's 3. So this distance right here is 3 units away. So we're going to go 3 units away here. 1, 2, 3. So there's 3 right here. So remember, we started at a half. So to go 1 unit, that's going to be like right here at 1.5. So 2.5. So this is 1.5, 2.5, 3.5. And that's going to be 3 away. So that's not, so 0.5, 1.5, 2.5, 3.5. Oh, I made a mistake. Do you see my mistake? I totally labeled this wrong. All right. I was like, what is going on here? So this is 1, 2, and 3. This is 3. Okay, and that's 4. Right. So yes, that's a 3.5. Just like that. Okay, so 3 units to the left, 3 units to the right. Okay, now the vertex is at -2, -8, and the point on the parabola is this. So again, we're going to take our, so I know my AOS is going to be x is equal to -2. It's always that x part right there. I know that this is at -1. So -1 is to the right of this, and that's going to be at -1, -7. So again, I know that the same height is on the other side. So this is going to be -1. Oh, so I know it's going to be something -7, right? Because the height stays the same, right? We just want to know the x parts, right? So how far is -2 from -1? It's just 1 away, 1 to the right. So we're going to go just 1 to the left, right? So we're going more negative, right? So that's going to be -3. All right. So that's our answer. It's going to be -3, -7. Some logical thinking here. So determine how to find another point on the parabola if you are given 1 point and an axis of symmetry. So given the axis of symmetry, the height stays the same. So we have the y coordinate, right? It's just our x that we need to figure out. How far is the x from the axis of symmetry? And then we're just going to do that same amount on the other side. Okay? All right. Well, that was your lesson for today. We got that now. We'll see you guys tomorrow. All right. I will see you guys later. Bye-bye.